Good afternoon, class. We are looking at exam 2 review covering chapter 3, differentiation rules. Exam 2, section 3.1 to 3.8. And here's the first part covering from 3.1 to 3.3. 3.1, derivatives of polynomials and exponential functions. 3.2, the product and quotient rules. 3.3, derivatives of trigonometric functions. 3.4, the chain rule. 3.5, the implicit differentiation. 3.6, derivative of the logarithmic functions. 3.7, rates of change in the natural and social sciences. 3.8, exponential growth and decay, and the rest of them are covered in the next exam. So differentiation formulas we should be comfortable with. Remember, dy dx is the limit of delta y over delta x as delta x approaches 0. The definition we normally use, f prime of x is the limit of f of x plus h minus f of x over h as h approaches 0. So that's the definition. Another formulas, the limit of x is 1, the derivative of x is 1, ddx. That's a differentiation operation, ddx. ddx of c times f of x, the c is a number, is a constant, and it can come out. ddx of f of x plus minus g of x is ddx of f of x plus minus ddx of g of x, meaning the derivative of the sum is the sum of the derivatives, the derivative of the difference is the difference of the derivatives. There are some definitions, some theorems that will help with some of the proofs, such as the limit of sine theta over theta as theta approaches 0 is 1. The limit of cosine theta minus 1 over theta as theta approaches 0 is 0. E has a couple of definitions. One of them is that the limit of 1 plus 1 over n to the power of n as n approaches infinity, or one may use x, as long as these variables, these three are the same, that's the same. The other one is that the limit of e to the power of h minus 1 over h as h approaches 0 is 1. The derivative of a constant is 0. The derivative, this is called the power rule. The derivative of x to the power of n is n, x to the power of n minus 1. The derivative of k times x is k. The derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of tangent is secant squared. Cotangent is minus cosecant squared. Secant is secant x tan x. Cosecant is minus cosecant x cotangent x. I'm giving you the synopsis of differentiation formulas, and we go through them, and over the course of the next couple of weeks, we get familiar with those formulas. CF prime. So instead of writing ddx of CF, we can write it in that fashion. Okay. So in essence, it's the same thing that you have here. The only thing that is different, so these three are the same as these three. This is called the product rule. F G prime is F prime G plus G prime if that's a shorthand notation. F over G prime is F prime G minus G prime F over G squared. If you've learned it differently, you can stick with that. But this, for those who know it, it makes it easier when you want to do the quotient rule, because it's the same thing, you use a negative sign. So the power rule again. Now, as far as the chain rule is concerned, the derivative of g of x to the power of n is n g of x to the power of n minus 1 times g prime of x. The derivative of e to the power of x is itself. The derivative of e to the power of kx is itself times k by the chain rule. The derivative of e to the power of g of x is itself by g times g prime by the chain rule. And the derivative of b to the power of f of x is itself times ln b times f prime of x. This is by logarithmic properties. This is by the chain rule. If it's so we are dealing with exponential functions. And composite function, the chain rule. The f of g, remember, is f of g of x. So f prime of, if we want to differentiate that, f prime of g of x times g prime of x, that means the derivative of the shell, the outer piece, the main function, times the derivative of the inside, or dy dx is dy du dx. That's Leibniz's notation. I know it's a lot of information. You don't have to worry about it. We are going to go through all of them. Natural law, when you take a derivative, is 1 over x. If it's a function of x, 1 over u du dx. So the natural log of g of x gives us 1 over gx times g prime. If it's a different base, then we tag along 1 over ln v, and that's because of the logarithmic properties. So if you have log f of x with base b, and you want to differentiate it, and 1 over f of x times ln b times f prime of x, this part is by the chain rule, and the trigonometric functions were explained. Now these are inverse trig functions. The derivative of sine inverse is 1 over square root of 1 minus x squared. Cosine inverse is the same thing with the negative one at top. And tan inverse is 1 over 1 plus x squared. Cotangent is the same thing with the negative one at top. Secant inverse, the derivative is 1 over x times x squared minus 1. And cosecant inverse is the same thing with the negative one at top. So that's the synopsis of those formulas. We will look at each and every one of them as we go through examples. Let us start with the simplest example we can come up with. Y is x to the power of 1000, and I'm going to remind you of the following formulas. The derivative of a constant is 0. The derivative of k times x is k, and the derivative of x to the power of n. This is the power rule. You put the n, the exponent in front, and then you drop the exponent by 1. That is the methodology. So, using this, 1000 becomes a coefficient. You drop the exponent by 1. You get y prime is 1000 x to the power of 999. Or you might say dy dx. That means the same thing. dy dx. Y equals 3r squared. We are taking the derivative with respect to r. R is the independent variable. On purpose, I'm using a different variable. Doesn't have to be x. So you want the derivative with respect to r, and it's the derivative of, you can write d dr of 3r squared. It's 6r, and let's just quickly justify it because this becomes 3 times. Now you take the derivative of r squared, which is 2 times r to the power of 2 minus 1, 2 minus 1, according to this formula, and that becomes 3 times 2, 6, r to the power of 1, or simply r. All right, let's differentiate this expression f of x equals x to the power of 8 plus 12x to the power of 5 minus 4x to the power of 4 plus 10x cubed minus 6x plus 5. And we are going to do it one by one. 8, x to the power of 8 uses the power rule. So 8 becomes the coefficient, and this goes down by 1. And so it's simply 8x to the power of 7. This one, this comes down, that means becomes a coefficient. So these two we will multiply. We get 60x to the power of 4. Same thing happens here. To bring this down, that means multiply these two numbers. You get negative 16 and drop 1 from the exponent, minus 16x cubed. Plus 30x squared. Now this one is this. The answer is minus 6. Because if you drop, remember the exponent is 1. When you drop 1 becomes the power of 0, which is 1. 5 is a number. So the derivative of 5 or 2 or 2000 or any number is 0. So this one gives us -6. We are done. All right, we're going to continue with the differentiation, and I am reminding you of the exponential rules, such as a to the power of 0 is 1, a to the power of m times a to the power of n is a to the power of m plus n, and so forth. I'm assuming we know those. So if it's square root of x, it's x to the power of 1/2. The reason we do that, so we can distribute and differentiate. So when we multiply this one, this has exponent 1, this has exponent 1/2. So take a look at this. When you multiply them, you add up the exponents. So this is 1, this is 1/2. We get 3/2, x to the power of 3/2, 5x minus 2. I'm assuming everybody's following that. This is elementary algebra. So what happens with this one, I want to make sure that I show that and how it works. If you want to differentiate this, 3/2 becomes the coefficient. You drop 1 from the exponent, x to the power of 3/2 minus 1. So you get 3/2 x to the power of 1/2. This gives you 5, a constant 0, and you're done. We put it back in the same format we received it. If you don't, it's not that big of a deal, but most of the time, you should put it back in the same format. We want to differentiate this expression, so we are going to go with the quotient rule here and say 2/9 times x to the power of 5 minus 9. 5 minus 9 according to this quotient rule, x to the power of -4. Because why do you put it in this format and you go with the negative exponent? So you can use the power rule of differentiation. And so here's what happens. I want to show you the step-by-step answer. So I want to differentiate this. I get 2/9 times -4 x to the power of -4 minus 1. So I hope you recognize this as minus 8/9 x to the power of -5. Now you have to have a positive exponent. You take it down. And so what happens is, this is the only calculus step. This is algebra. This is algebra. I hope everybody's comfortable with that. ddx of pi squared. I hope you recognize pi squared or pi or e or 2000. They're all numbers. They're all constant. Any constant, the answer is 0. Recognize this as a number. The derivative of any number, any constant, is 0.
Professor, would it fall under the rule for exponents? Because it's
No. It's a number. It's not x squared that you say the answer is 2x. This is a number. The
Oh, I see what you're
derivative,
saying. I see
the
what you're saying.
derivative of any number, pi squared, pi, e, 10. Notice this is a number.
Okay, so because it's a value squared, it's going to give you a value, and any value derivative is 0.
The derivative of any constant, any number is 0.
Okay.
Excellent. Does that make sense?
Yeah, that makes sense.
Perfect. We are going to look at the product rule. And as a warm-up example, we are going to go with the first step and differentiate, because there are more steps for combining, simplifying. I want to show you the most important step, which is the actual differentiation. Shorthand notation, fg prime is f prime g plus g prime f. So we are going to call the first parentheses the function f of x, and the second parenthesis the function g of x. And so according to the shorthand notation, we are going to differentiate this, multiplied by this, plus we're going to differentiate this, multiplied by this. And that's the only calculus step. The rest of them, simplification, would be algebraic steps. So let's start with this. The derivative of the red function is 4x cubed minus 6x squared. This is a number. You don't have to worry about it. So this is f prime times g. Just write the second parenthesis without making any changes. Plus g prime. So we want to differentiate this. We get 6x minus 5 times f, the first function, without changing anything. And believe it or not, we're done with calculus. Of course, there are several steps left to finish this off. We don't want to simplify it. I just want to emphasize this step, which is a calculus step. As long as you can do that, the assumption is you can finish it, because the assumption is you have no problem with algebra whatsoever. Now, we want to differentiate this one. Y equals x squared times sine x. Please understand it's a product rule, so I'm going to put a raised dot in between, and then I'm going to call this the f function, and this one the g function. Again, shorthand notation. So I am looking at the product of x squared and sine x. Therefore, I must use the product rule. F g prime plus g prime f. F g prime is f prime g plus g prime f. So this is the first function. Differentiated, you get 2x times the second function g. So this is f prime times g, the sine x. And then the second function, you're going to differentiate g prime, the derivative of sine. Remember, the derivative of sine is cosine, the derivative of cosine is negative sine. So you take the derivative of sine, you get cosine x times f, the first function unchanged, times x squared. I'm going to write at top of him that this is f prime g, this is g prime f. And we just rewrite it. Rewriting meaning this has to come in front, because we don't want anybody to be under the assumption this means cosine of x cubed, because I've seen that happen, and that is wrong. You can factor out the x, but doesn't change anything. So that's the final answer. Differentiate y equals 5x times 3x minus 2 to the power of 4. To differentiate this, if this number is involved, you really want to separate them and put this in brackets. In this case, it's not a big deal. Again, if it's a fraction, it's a decimal, or it's a huge number like, let's say 5,000, you really want to put brackets here and deal with this and put the 5 out because it gets multiplied by everything. However, if you just go with this one being the f function, this one being the g function, so you're looking at the product rule, f prime g plus g prime f on the one hand. On the other hand, when you get to differentiate this, you are dealing with the chain rule. The derivative of g of x to the power of n is n g of x to the power of n minus 1 times g prime. So let's stick with the program. Let's go with the product rule. First, 5x. So it gives you 5 times g, just times the second piece, plus g prime. Now we want to differentiate this. How do we differentiate it? We follow this. The derivative of a function to the power of n sits in front. So it's really the power rule, and this is called the extended power rule. So this is the extended power rule, or the chain rule. Now, so we want to differentiate this, and we're going to follow that n, that means plus 4 times g of x to the power of n minus 1, this thing to the power of 3. Now, here's the idea behind the chain rule. The difference is here. Now we want g prime. That means we want the derivative of the inside. The derivative of the inside, the derivative of the parentheses, is just 3. So this is simply, all of it is g prime times f 5x. So I'm going to put that at top so you can see we are dealing with f prime g plus g prime f. And we are done with calculus class. Now we are going to use our algebraic techniques to finish the job. Okay? And that's important to understand. The reason I mentioned we are done with calculus, because I want to emphasize the importance of knowing algebra, prior knowledge of mathematics, because if we do, it makes life easy. Okay? And so, with that being the case, we are going to simplify by factoring things out. And you can do it just the way it is, but to make sure we understand what's going on, please notice 4 times 3 times 5 gives you 60, and we put the x in front. So the second piece, let me clean up so it becomes easier to see. The second piece is this one. So between these two, this is one expression, this is one expression. I'm going to go with factoring. Number 5 is in common. 3x minus 2 is in common. Exponent 4 versus exponent 3. 3 is in common because you are going to choose the smaller of the two. I'm just reminding of the factoring. So what's in common? 5 times 3x minus 2 cubed. So when you divide this one by this one, this just gives you 3x minus 2. When you divide this one by this one, 60 divided by 5 gives you 12 x, and this cancels out this one. So again, it's just algebra. And of course, these two add up to 15x. So the brackets changes to 15x minus 2. Everything else remains unchanged. Now, what I want to add is the importance of understanding if this number is involved, you don't want to go this route. In which case, if that happens, you put this in brackets and you differentiate this, you keep everything in brackets and the 5 out. So in that case, 5 remains. This gives you 1 times this piece plus this piece. We've already done that. Gives you what? 4 times 3x minus 2 cubed times 3. Okay. And then times x. In other words, instead of 5x, you multiply by x. Go ahead.
Where'd that times 3 come from again? After you do g of x?
You're talking about this one?
Yes.
This is g prime of x, the derivative of the inside, 3x minus 2. See, 4 is the exponent. 3x minus 2 cubed, we take it down by 1 notch. And then
Okay.
g prime of x is 3. And so if you put the 5 out, this is the way it looks like. Of course, you have to finish it. But my point is, either way, there's only one step of calculus. Everything else is algebra. Y equals 1 over 7x squared minus x to the power of 4. To differentiate this, we are going to use the power rule, or for that matter, the extended power rule. So we are going to put it in a format so that power rule can be used. So we bring it down to the power of -4. This is algebra. Now we are going to follow this. So y prime is -4. That's your n. G of x to the power of n minus 1. This one to the power of n minus 1. Minus 4 minus 1 is minus 5. Okay, let me just make sure everybody understands. So this is n g of x to the power of n minus 1. Finally, we need g prime of x. We need the derivative of the inside, which is 14x minus 1. So this part is g prime of x. This part is by the chain rule. And again, this is your only calculus step. You're done. Now you do algebra to finish it. So to do the algebra, basically, you take this expression down and you make it to the power of +5. So -5 changes to +5. And that's a must. You have to do that. So we are looking at the power rule, the product rule, the extended power rule, which is using the chain rule, of course. We are going to move on. Again, a warm-up example using the quotient rule: differentiate, do not simplify. Bear in mind, this requires simplification, everybody, after you do that. However, there is no need to do that for this specific question. And to do so, we are going to follow f over g prime is f prime g minus g prime f over g squared. We're going to give it a name. The top is the f function, the bottom is the g function. And so according to this, f prime g minus g prime over g squared. So f prime, we're going to differentiate this. We've done that before, and we did the product actually. 4x cubed minus 6x squared. This is a constant, gives you 0. So this is your f prime times g. Just write the bottom here. Just multiply by it. You don't have to change anything. So what you're looking at here is f prime g. Minus g prime f. So here's the g function, the bottom function. Its derivative is 6x minus 5 times f, the top function. And then you have a fraction bar, and all you have to do, repeat what you see here in a parenthesis and square it. You don't have to do much. So 3x squared minus 5x to the power of 2. Now, of course, it says do not simplify. This is the only calculus step. You have a couple more steps to go to finish the job. That's not the purpose of this question. What is the purpose of this question? Showing you how the quotient rule works. Example 4, differentiate quotient rule with a question mark. F of x is 10x squared minus 7x cubed over x squared. It is important to know whenever you have to use the rules such as quotient rule or the product rule, you have to use it. But specifically in the case of a quotient rule, if you don't have to use it and you use it, it takes a lot longer to get to the answer if you can finish the job. Normally, students who don't see the easy way out, they can't finish the job anyways. Do I have to use the quotient rule? The answer is absolutely not. So what do you do first? You do algebra. This is 10. This is minus 7x. The derivative is simply minus 7. So the answer in a split second is minus 7. It can't get any easier than that. The point being, you don't always have to use the quotient rule, especially if the bottom has one term. Sometimes it's not even a term. It may be a square root of x. You change it to x to the power of 1/2, and you do the same thing as we did here. So be careful when it comes to that. All right, we want to find the limit of sine 3x times sine 5x over x squared as x approaches 0. There are a couple of theorems that are being used here. Sine theta over theta as theta approaches 0 is 1. The limit of cosine theta minus 1 over theta as theta approaches 0 is 0. It's important to pay attention to this one, and this one must be identical for it to work. So, and it's important to know when you're dealing with sine and cosine, you got to pay attention to the argument of sine. Here is 3x. The argument of sine is 5x. You can't do anything about the argument. You can't change that. So what you do, you are going to separate this fraction into two fractions. And when you look at this one, the argument is 3x. You can't change that. So what can you do? Well, you're hoping to get these 3 the same. If you multiply this one by 3, then you have to multiply the top by 3. You can do that. the effect of that, this 3x is the same as 3x, and that's what you want. This one is 5x. You can't change that. But this fraction, if you multiply the bottom by 5, you can multiply the top by 5. Now, this one, you take this 3 out of the limit. And by the way, the limit of this piece times the limit of this piece. This is the limit laws. So this one, you take the 3 out. This one, you take the 5 out. So take a look at what happens here. Now, x is approaching 0. You have 3x here. And of course, if x approaches 0, so does 3x. This is 5x. This is 5x. So far, so good. We want 5x to go to 0. If x goes to 0, so does 5x. You have to change it accordingly. Now, you have two choices. Say, okay, this one, and this one are identical. This is 1, so the answer is 3. This one, and this one are identical. The answer is 5. 3 times 5 is 15. If you want to make the change like that, you can say, take a look. You can say this piece, and I'm going to do one of them. This is the same as 3 times the limit of sine theta over theta as theta approaches 0. In this case, you let theta represent 3x. Do you follow what I'm saying? You don't have to do that. 3 times 5 is 50. The limit of cosine theta minus 1 over sine theta as theta approaches 0 is missing. And again, we can only use those two. To do so, we want to make it look like one of those. The technique here is to look at this one, the denominator is theta. Look at this one, the denominator is theta. So if I divide the top and the bottom by theta, that's fine. And by the way, remember, theta is not 0. Theta is approaching 0. So this is acceptable. So this looks like the bottom. This looks like the top. We are going to apply the limit to the top and the bottom separately. This is 0. This is 1. 0 over 1 is 0. The limit of cosecant x times sine of sine x as x approaches 0. So if you look at this one, these 3 must be the same. Pay attention to that. So this is sine of something. Imagine this is theta. So if we had the denominator to be theta, then we would be probably in good shape. So remember, cosecant x equals 1 over sine x. So we can write it in this fashion. So pay attention to what happens here. So this is sine x. You bring it down. This is sine x. Since x approaches 0, so that's sine x. Remember, sine of 0 is 0, right? So now, let sine x be theta. You can say this is theta approaching 0. This is theta approaching 0. This is theta. Okay? So the limit of sine theta over theta as theta approaches 0, and that's 1. If you don't change this to that, it's okay, but understand the concept. The limit of sine x squared over x as x approaches 0. Again, somehow we want to use the theorems given. We notice it involves sine, so we probably have to go with sine. How do we do that? Well, sine theta, these three must be the same. And remember, this one you can't change. Class, you cannot change the argument of sine. So if the bottom was x squared, we would be in good shape. And it's not. Okay, so multiply by x and divide by x. Okay, so I put the x up here, down here. I'm multiplying the top and the bottom by x. So this looks just like that. And that's what we want. This is x squared. This is x squared. Now, we separate them into two limits. The limit of x as x approaches 0 times the limit of sine x squared over x squared as x approaches 0. Please note, when x goes to 0, so does x squared. You can't just change the x to x squared. Because x goes to 0, x squared goes to 0 also, and you want this to be identical to this, for you to use this theorem. So now this is 0, right? So is this one. This is, my apologies, 1, and the product is 0. 0 times 1 is 0. So this is 0. This is 1, but the product remains as 0. We want to differentiate y equals 1 plus sine x over x plus cosine x, and we recognize that we need to use the quotient rule. To do so, let's call this top function the f function, the bottom the g function, and use the shorthand notation f prime g minus g prime f over g squared. So we have y prime equals, we have a fraction bar, the derivative of the top. This is 0, sine gives you cosine. Times what? Times g. So put the bottom here. G. X plus cosine x. Minus, now g prime. The bottom gives you the derivative 1 plus, cosine is negative sine, so 1 minus sine x, and then times f, times the top function. And all you have to do, just repeat the same thing here, g, and square it. So put this in a parenthesis and square it. That's it. You are done with calculus. We are going to simplify f prime g minus g prime f over g squared. We're done with calculus. We are going to simplify. So this is x times cosine x. This is cosine squared. 1 minus sine times 1 plus sine is 1 minus sine squared, because everybody knows that a minus b times a plus b is a squared minus b squared. Okay, class? Let's see what we know about trigonometric identities. We should know sine squared plus cosine squared is 1. We should know tan squared plus 1 is secant squared, and 1 plus cotangent squared is cosecant squared. These are called Pythagorean identities. Okay, Pythagorean identities. The first one is proved using the unit circle, and the other two, all you have to do, divide this one, both sides, by cosine squared, you get this one. Both sides divide by sine squared, you get the third. So the proof is very simple. Now, when we know that, that means obviously we know that cosine squared is 1 minus sine squared, or sine squared is 1 minus cosine squared. So those are given, okay? Therefore, we should know this is cosine squared. So we have this one, we have this one, and we're going to replace this with cosine squared. These two cancel each other because they are opposite. And the final answer is x cosine x divided by x plus cosine x quantity squared. That's the final answer. If we don't know algebra, trigonometry, it can make it very difficult. Derivative of trigonometric identities are given here. For example, as I said, derivative of sine is cosine, cosine is negative sine, tan is secant squared, cotangent is minus cosecant squared, secant is secant tan, and cosecant is minus cosecant cotangent. So what we say is that we know the derivative of tan x is secant squared. Let's look at the proof. Let's prove this. The derivative of tangent is secant squared. Let's prove it. Well, tangent is sine over cosine. We should know tangent is sine over cosine or 1 over cotangent x. Cotangent is cosine over sine or 1 over tangent x. Secant is 1 over cosine, cosecant is 1 over sine. Those are trigonometric identities. Some of them. This one, this one, this one, and this one are called reciprocal identities. And these two are called quotient identities. All right, now when we look at this one, we say, okay, it's f over g, so we are going to use the quotient rule on this. Why are we doing that? Because we know the derivative of sine, we know the derivative of cosine. So according to this, we are going to say f prime g minus g prime f over g squared. We start with f prime and we put the cosine x at top times g. Just put the denominator cosine x minus g prime, the derivative of cosine is negative sine x times f sine x. Then you just put the bottom and square it. That's g squared. So cosine squared x, and done. With calculus, we are going to finish the job using trigonometric identities. So just to give you an idea, what we are looking at is f prime g minus g prime f over g squared. The top is cosine squared plus sine squared. And we all know Pythagorean identity, this is 1 over cosine squared. So if 1 over cosine is secant, 1 over cosine squared must be secant squared x. What about what I call secant x? We are saying the derivative of secant is secant x times tan x. Let's prove that. We know secant x is 1 over cosine x. We are going to use quotient rule on that. So we are going to write f over g. F of x is 1, g of x is cosine x. So we are going to use the same quotient rule, f prime g minus g prime f over g squared. So a fraction bar, the derivative of 1 or any other number or constant is 0 times g times cosine x minus g prime, the derivative of cosine is negative sine x times f, the top function is just 1, over, just write the denominator and square it. Denominator is cosine, just write cosine squared. Again, I'm going to write this for you. This is f prime g minus g prime f over g squared. The top becomes, this goes away, positive sine x. And now we want to get to this. We are going to separate this into two fractions, 1 over cosine x times sine x over cosine x. As you know, this is secant x, this is tan x, according to what I've given you here. Again, I'm assuming you know all of this, or at the very least, when I go over that, it's coming back to you, okay? Because you need to be very comfortable with those. So we proved the derivative of tangent is secant squared, and we proved the derivative of secant x is secant x, tan x. Of course, using a lot of identities that we've learned from trigonometry. We want to differentiate, and obviously we are going to use the quotient rule, where the top is 1 minus secant x, the bottom is tan x. So we're going to go with the quotient rule f prime g minus g prime f over g squared. So we are going to differentiate the top. 1 gives you 0, negative secant x gives you negative secant x tan x, times g, the bottom is tan x, everybody, minus g prime, the derivative of tangent is secant squared, so minus secant squared, times f times the top, you just put this here, put this one here, 1 minus secant x, and then over g squared. Just repeat that down here and make it squared, so tan squared. And believe it or not, again, let me put an asterisk next to it because it's important to see that you are done with calculus right here. The rest is your algebraic techniques, knowledge of trigonometry, you name it. So we're going to continue on that thoughts. So obviously this is minus secant x tan squared. This is minus secant squared. This is plus secant cubed. The denominator is not changing. From the top, we can factor the secant x out because they all have secant x in common. And if we do so, this is negative tan squared. This is minus secant x. This is secant 2 secant squared x when we take the secant out. So the numerator, we can take out the secant x. Now, remember the identity 1 plus tan squared is secant squared, which means I can move the tan squared to the other side. That's just the same. We just move things around. And notice this one and this one, they add up to 1. You replace those two with number 1. So those two have been replaced with 1. So the final answer is secant x times the brackets 1 minus secant x over 10 squared. Again, knowledge of algebra and trigonometry is a must. Differentiate y equals cosine x over 1 minus sine x. Again, we're going to go with the quotient rule, where the top f of x is cosine x and the bottom g of x is 1 minus sine x. So f prime g minus g prime f over g squared. We are going to write f prime, that means the derivative of the top, or negative sine x, times g, the bottom function, 1 minus sine x, minus g prime. Now, what is the derivative of the bottom? 1 goes away, so minus. The derivative of sine is cosine, so minus sine x gives you minus cosine x. So this negative sign is from here, and minus cosine is the derivative of minus sine times the top, because it's f, and cosine x. You just write the bottom in a parenthesis and square it, and you're done with calculus. Again, I'm going to put the asterisk next to it. This is done. Now use your algebraic techniques, knowledge of trigonometry to finish the job. So to do so, this gives us negative sine x. This gives you positive sine squared. This gives you positive cosine squared. And you just repeat the bottom. There's nothing you have to do. So what you have is that you can put these two together as 1. So what are we looking at? The numerator is 1 minus sine x. The denominator is 1 minus sine x squared. So this is 1 minus sine x times 1 minus sine x. This is 1 minus sine x. So this can go away and you drop the exponent. I hope everybody can see the algebra here. 1 minus sine x. This is 1 minus sine x squared. And you drop one of them from the top and the bottom. That is the final answer. Again, algebra, trigonometry, all at work. Find an equation of a tangent line to the graph of y equals e to the power of x cosine x at 0, 1. To find the equation of any line, you need a pair x comma y. They may give you the pair, or they may give you the x coordinate only, at which case you put it in and you find the y coordinate. The second thing you need is the slope. To find the slope, you are going to differentiate and then evaluate it at the x coordinate. So we are going to differentiate, and to do so, I'm going to put a raised dot here, showing everybody that I have to use the product rule. And so f prime g plus g prime f. So e to the power of x is itself times cosine x, minus cosine is sine x times e to the power of x. I hope everybody's comfortable with that. By now, we've done it in step by step. You should be very comfortable with this. So this is, everybody, f prime. Remember, the derivative of e to the power of x is itself. This is g minus g prime f. Okay. So one more time. E to the power of x is itself times cosine x, plus cosine gives you negative sine x times the first one, e to the power of x. So you can factor out e to the power of x. Now, this is y prime, and it is not the slope of a tangent line. It becomes the slope of a tangent line when you pick any x coordinate. Specifically, we want at x equals 0. So if you plug in 0, what do we get? We get e to the power of 0 cosine of 0 minus sine of 0. And I hope you know that sine of 0 is 0, cosine of 0 is 1, e to the power of 0 is 1, and the answer is 1. And because this is the y-intercept, that means b equals 1, you can use y equals mx plus b. So m is 1, b happen to be 1. They are not always the same. 1x plus 1. So again, y equals mx 1x plus b. Again, b happen to be 1. Okay? Doesn't mean that it's always the case. Find the points for which the tangent lines are horizontal. As you know, horizontal lines, they have a slope that is 0. So all you have to do, find f prime of x, which is 3x squared minus 6x, and set it equal to 0. Why 0? Because we are saying it's horizontal. Okay? When we say horizontal, we are giving the slope. So you find this by factoring the 3x out. Either x is 0 or x is 2. Now, those are 2 points, meaning if you plug in 0, everybody here, gives you 0, comma, 5. If you plug in 2, you get 2 cubed minus 3 times 2 squared plus 5, which is 8, minus 2 squared is 4 times 3, 12, plus 5, which is 1. That means 2, comma, 1. There are 2 pairs at which the tangent lines are horizontal. 0, comma, 5, 2, comma, 1. They may just want the x coordinates. So it depends how they ask you.